Hello friends, in this lecture we are going to learn about how to simulate an electronic circuit. So this is our ISIS software, and we are going to learn how to simulate a simple full wave rectifier. So for doing that we need some diodes. So this is generic diodes, and we are going to put it this side, and then we have to make it a okay. So now we will copy it. Now we'll form a circuit. Now for this we need a sine voltage. So this is a sine wave AC volt source. So sine voltage source, this is connected over here, and this is connected over here. Now this is sine voltage generator, and now we are converting it into AC into DC. So we need a resistor. This resistor is going to be over here. We will rotate it. Now this will going to connect here, this is going to connect here. Now if we just play it, so animation is running, and there is two messages. First is the electronic boot and load. This is the design file SDF. So now, but here we are not going to learn that, like what is going on. So for that we need a oscilloscope. So we will put oscilloscope over here. So this is the input AC voltage, this is half wave, and this is another cycle half wave. Now we will just play it and see what's going to be here. Okay, now here this is showing nothing. So for that we have to just change some commands over there. So first of all, okay, we have to give its 100 amplitude, frequency will be 50 Hertz. Now this is 100 volt 50 Hertz supply, and this resistor is going to be okay, 1K. This is 1K. We can change its value like this, 1K, and now we will play it. Okay, so now we can see this kind of structure over it. Then we have to simulate it. Now we have to just control some parameters so we can get a very good picture of it. So now okay, good, okay. Now here is this yellow. This yellow graph is the sine wave which we are generating from this V sine voltage, and this blue line is a half wave. This is 0 full, 0 full, 0 full. This is this half wave, and this is the third one is okay, the third one is the another half wave. This is negative 0, negative 0. We can check it like this. Okay, this is 50 volt. This is around 50 volt. This is around minus 50 volt. This is positive 50 volt. this is 0 volt. Okay, 0 volt. This is minus voltage, this is minus 46 volt. So this is the sine wave, this is the positive part, this is the negative waves. Now what happens when we do A plus B? Then we can find this DC voltage over there. Sorry, we can't just do A plus B because we have connected our supply over A and this over B, so we have to just remove this from B. So we just have to go outside the simulation, then the B is this. Okay, so delete this wire and we have to connect, this is on D. So when we just play it, so we will found D over here. So we just have to first of all make it measurable, and this is our G. Okay, so this is our positive and this is our positive wave, this is our negative wave, this is our input. So this is input, this is output, this is output. When we do C plus D, so this is gonna give us the simple DC voltage. So it is DC, so there is no fluctuation. Plus 50 volt plus minus 50 volt, it is going to give us 0. So when we do C plus D, so this is how we can find out how a simulation is actually working. Now this is a diode. Okay, so there is no any triggering issue over there, so we just remove it. Now we need SCR. This is a semiconductor resistor. This is 1, this is 2, this is 3, this is 4. These are gonna connect like this. This will be same as for the diodes, but there is something which is different, and I'm gonna tell you now. And we just have to connect it as we had connected diode before this simulation. Now C is connected, D is connected, and A is connected. Now we have to just contact this. Okay, now when we just play, we check what is this everything is connected. Yes, okay, everything is connected. We will just play it. So digital oscilloscope. Now we can find this kind of structures over there. This is our input and these both are our outputs. We can see this is the perfect positive and this is the another part. Now every SCR has a triggering point, so to add this triggering point we can actually add some pulse generator. This is the pulse generator. Okay, now we just put this generator over there, second, third, fourth. Now 1, 2, 3, and this is the this is the fourth one. Now in here, okay, now here we can add whatever we want to do. This is the pulse. Okay, so what is the pulse high voltage? So we will take it 2. Okay, pulse width 50, frequency should be 50 hertz because we are working under that phenomenon. So again this is 50, pulse width percentage, it is the 50%, and this will be 2. Okay, third one is 2, this is 2, this is 50, save. Last one 2, this is 50, this is 50, save. Now we here have this B. Okay, so we just take a sample from here, so we can check that is this really working or not in the oscilloscope. Now we will just have to play it, and okay. So this is the pulse, this is the pulse which we are giving from there. This is 50%, so this is exactly that. Okay, this is the positive side. Okay, this is high, so this is showing, this is high, so this is showing, this is high, so this is showing it. Okay, now for C, this is the first half, we can check it over there, and this is the another negative size. Okay, so we can see here, like this is exactly depending upon the firing angle. This is the firing which we are going. So when this is high, it is showing output. When this is low, this is not showing. As here we have only connected this one over here, that is why it is showing only its pulse over there, but there are 4 pulse generators, so 1, 2, 3 and 4. So for one this is showing this, for another one this is showing this, for third one this is showing this, and for fourth one this is showing this. So the basic resistor, how basic rectifier work, like when the voltage, when current comes from there, this go like this, from there it flows through the component and then come through this and go into the ground. Okay, from there to like this and ground. For the next cycle, when the polarity changes, then the current flow like this, again this, and from this. So whenever the polarity changes, the direction of current changes, and that's why we got 2 waves over there. This is a positive, this is the negative. Okay, and whenever we join these two, we will find out something like this. Okay, C and D. Now this is how it actually works. And now when we have to control this, we can just to control this SCR by using this pulse generator. It is 50, it could be, its value could be changed, and when its value changes, the main diagram changes. So this is how we can control and check whether electronic circuit is working or not by using the simulating softwares. And we can also change the internal properties, such as on which firing angle we have such graphs. And again, one day we have checked the bill of materials. So this is the bill of materials. Okay, resistor, integrated circuit, SCR 4, and one V1. what a sense. So whatever we have used as a component, it is here. This is done for the, so we are done for the today's tutorial. Thank you.